The childhood dream has finally come true. Building a house is now like stacking toy bricks. This is a genius design from Belgium that replaces traditional bricks with large blocks similar to toy bricks. There's no need for steel or cement. By simply stacking these blocks together, you can build a house layer by layer. This method is called building with block bricks. It's reported that the outer layer of the block is made of OSB wood, while the interior is filled with EPS insulation material. Each block weighs about 7 kilograms. Before construction begins, a computer generates a 3D model of the house, precisely calculating the number of blocks needed, avoiding the problem of material shortages or surpluses commonly seen in traditional construction. Once the blocks are ready, they are packed and shipped to the construction site, along with detailed assembly instructions. Workers just need to follow the blueprint, slot the blocks together by connecting the protruding and recessed parts, and the walls are easily built, just like stacking toy bricks. To provide structural stability, vertical support beams are placed between the blocks, which not only serve as pillars but also reinforce horizontal connections. Next, the ceiling for the second floor is installed. After laying the flooring, insulation materials are placed inside the frame, and the structure is then covered with wooden boards. Following the same method, the walls of the second floor are built. The slope and shape of the roof can be designed according to the homeowner's preference, and the blocks can be custom made. Finally, a sturdy and well-insulated house is complete. What do you think? Isn't this building method amazing? With a snap, the person immediately fell down. This is the direct answer to the question everyone often asks. Will a trampoline break when you jump on it? You could say, the more fun you have while jumping, the more painful it is when you fall. Fortunately, in most cases, the final elasticity of the trampoline can absorb the impact of a person falling, so the injuries are not too severe. As for how high the probability of a trampoline breaking is, in fact, it is directly related to the price of the trampoline. Although all trampoline mats are primarily made from a composite structure of nylon and rubber, the amount of material used is determined by the price. Some higher-priced models are obviously more durable. Even if more than a dozen people are jumping on it, in the end, only the trampoline frame might break, not the elastic mat. On the other hand, with cheaper models, you need to be careful. Sometimes, even if there's only one person on it, it still can't hold up. With almost no warning, a big hole could appear at any time, trapping you there. So if the trampoline is sturdy enough, how high can you actually jump? In reality, if you rely solely on the strength of one person, even jumping from a high place won't cause much of a rebound. But if several people jump together, it's a different story. You can see that the main jumper in the middle, with the support of people around them, can reach a height of up to 13 meters. This is currently the highest jumping record in trampoline history. In addition to jumping high, trampolines also have a stress relief effect in certain conditions. For example, jumping on a trampoline after it has frozen in winter will cause countless shards of ice to bounce up when the body lands on it. Isn't that fun? What might seem unusual is actually part of the aging process for jeans. Since jeans are cut from uniform fabric, factories use various techniques to create differentiation and align with the trends of young people. The aging process, also known as distressing, helps make each pair of jeans unique and stylish. The simplest method involves workers directly cutting, sanding, or making holes in the jeans to achieve a worn look. More advanced techniques include using machines for cutting and sanding the fabric, or applying lasers to burn patterns into the material. Some methods also involve pressing the jeans on machines to create natural-looking wrinkles or spraying paint for coloring. The device seen at the beginning is a jeans shaping tool that mimics human leg movements. This equipment uses heated air in a closed environment to produce more natural and realistic wrinkles. The result is jeans that appear older, more worn, and more vintage. This method ensures that each pair of jeans has a unique character, reflecting the style and personality of the wearer. In a long water tank, a small wave seemed to roll forward steadily, but when it hit the metal plate, it suddenly splashed up a huge wave. Because it comes quickly and goes just as fast, like a wind dog that bites you and then runs away, people call this type of wave wind dog wave, and this long water tank is actually a place to simulate wind dog waves. In such a small space, the wind dog wave produced is already so powerful, let alone in the vast and boundless ocean. You might think it's just a small wave, but the next second, a wall of water tens of meters high could hit the front glass of the ship. Because it's difficult to predict precisely when it will appear, people can only study it through artificial waves. Data shows that when waves from different directions collide at different speeds, it is easy to generate wind dog waves. At that time, a ship originally sailing smoothly on the sea might face a wall of water formed by waves converging from multiple directions ahead, giving it no time to dodge and forcing it to collide head-on. However, if the waves hit from the side of the ship, even a 12-meter high wave can exert a braking pressure of 6 tons per square meter, leading to unimaginable unimaginable consequences. So far, today's equipment still cannot accurately predict wind dog waves because, besides the factor of waves from multiple directions, it also involves wind speed, wind direction at the time, and the seabed's topography. This is a dramatic scene captured by surveillance cameras. Steel bars heated to nearly 1200 degrees Celsius were ejected from the production line, even hanging from the ceiling. This represents the dreaded thermal explosion phenomenon that steel mills never want to experience. To understand this event, one must start with the production process of thermal steel. Initially, steel billets are sent into the furnace for high-temperature forging, heated to above 1100 degrees Celsius. During this process, an oxide layer forms on the surface of the steel. Before entering the thermal mill, this layer is washed off with draining water and cooling water to improve the quality of the steel and its subsequent processing performance. The steel billets then enter the roughing mill, where they are continuously compressed and stretched into thinner bars. After roughing, the steel undergoes multiple cooling and reheating cycles before entering the finishing mill for further processing. The diameter of the steel decreases progressively. If the gap between the steel bars and the thermal mill opening becomes too large, the bars may accumulate at that point. In severe cases, this results in the dramatic scene seen in the video resembling a fiery serpent swirling in the air. Faced with such a sudden occurrence, workers are powerless, having to wait until the steel is fully ejected and cooled before cleanup can begin. Finally, the processed steel bars, with a diameter of about 9 millimeters, are ejected from the machine in a coiled form. As the conveyor belt moves forward, the cooled steel bars automatically fall into the coiler, continuously rotating and wrapping until a finished coil of steel wire is produced. What should you do if a semi-trailer experiences a dangerous sway while traveling at high speed? This is a perilous moment that semi-truck drivers most fear, when the rear of the truck sways uncontrollably, increasing the risk of a rollover. So, how can this be avoided? Firstly, this situation can occur with various types of trailers, and the main cause of swaying is uneven load distribution. For example, in the trailer model shown in the video, when the load at the front is greater than at the rear, even if swaying occurs, the trailer can quickly self-correct. However, if the load at the rear exceeds that at the front, even a slight external force can trigger severe swaying. If the driver handles this situation incorrectly, it could easily lead to a rollover, and in severe cases, endanger the driver's life. The correct approach is to avoid braking, keep the steering steady, and continue accelerating forward. By using forward momentum, the swaying forces from side to side will be counteracted and neutralized. Braking will only reduce forward momentum, increase the side-to-side swaying forces, making the swaying worse and increasing the risk of an accident. In addition to cars, almost all two-wheeled vehicles can also experience dangerous swaying. The cause is usually a change in the front wheel's trail distance. Trail distance is the distance between the vertical line from the tire's center and the extended line of the steering column to the ground. When the front wheel is misaligned and the trail distance decreases, the front wheel becomes extremely responsive. The more you try to correct the steering, the easier it is to fall. The right approach is not to brake or accelerate, just ensure your arms are relaxed and do not pull on the handlebars. You can see that the swaying motorcycle, after throwing off the assisting rider, can still right itself and continue chasing other competitors. Using scissors to cut down a large tree. Have you thought of this trick? You can cut down the entire tree at the root, or cut it across the middle. After replacing the excavator's bucket with this scissor device, you can cut whichever part of the tree you want. Just control the scissors to cut that part. You can also lift the cut tree and place it wherever you like. This is an incredible tree cutting machine. The machine only has a single cutting blade, which is designed at the bottom of the device. Once you've determined where to cut the tree, simply control the machine to approach the tree. The mechanical wall on top will first unfold, cutting from one side of the tree to the other. Powered by hydraulics, it takes no more than 10 seconds to cut down a large tree. At this point, the cutting head won't retract immediately, but will be used as a tray. Combined with the mechanical wall above, it will lift the tree and place it wherever you want. Since the cutting is done by sharp blades, the entire process is noise-free. In addition, you can replace the blade with a chainsaw. The principle and operation remain the same, just with a bit more noise. Using this machine to cut trees not only increases work efficiency, but also reduces the effort needed from forestry workers. How about that? Isn't it amazing? This video was filmed on September 10th, 2020, at the site of a domestic wind power project, where a major wind turbine hoisting accident occurred. It's over! It's over! In the end, a 1,200-ton crane broke, and 3 wind turbine blades fell to the ground, resulting in severe damage. The losses were quite significant. Actually, according to the situation at the scene, the 3 blades should have been installed separately, but this method was time-consuming. To speed up progress, the construction team assembled the blades on the ground, and then lifted the entire set with the crane. One can only say that how things progress afterward depends on fate. Each year, wind turbine hoisting projects experience various accidents, both large and small. In minor cases, they lead to equipment losses worth millions or billions. In more serious cases, they may result in human casualties. And every time an accident happens, the workers on site can only watch helplessly and, with great unity, say the same familiar words: "It's over. It's over."